Liquid-only roadway treatments are becoming increasingly popular as a tool for preventing the bonding of snow and ice to our roads and for removing snow and ice during storms. Public works agencies across the United States are using liquid-only treatments due to their ease of use, low costs, and fast response times. However, there are many misconceptions and misunderstandings that people hear about these types of treatments. In this video, we will discuss the benefits of liquid treatments, describe how they work, and address common myths. In doing so, we will demonstrate why liquid-only treatments are a safe and reliable solution for snow and ice prevention and removal. What are liquid-only roadway treatments?
Liquid-only treatments are an important component of doing everything you can to minimize ice formation on the roads prior to a storm coming in here in the city of Prior Lake.
Liquid-only roadway treatments are used for anti-icing and de-icing. Anti-icing is a proactive treatment that occurs prior to the start of a storm event. It prevents snow and ice from bonding to the roadway surface. De-icing occurs during or after a storm to remove existing snow and ice, or to aid in loosening snow for plow trucks to remove. The liquid treatments are usually a brine solution of water and a compound, such as rock salt, sodium chloride, or magnesium chloride. Although these compounds both create salt brines, the term salt brine typically refers to a sodium chloride brine. These brine treatments can be used in place of solid salts or aggregates during certain weather conditions.
Liquid products are much more effective of getting us back to bare pavement, of burning off that last little bit of pack than opposed to granular products.
Why use liquid-only roadway treatments?
Liquids are easy to put out. They'll stay on the road and they won't blow off like a solid particle will. If you're going out and trying to anti-ice or get ahead of a storm with a solid granular material, good chance that's all going to blow off the road.
When you're applying liquid material to the roadway, it stays in the roadway, in the travel lanes, for the traveling public that you are trying to benefit. Whereas with granular material, even at the recommended 25 miles per hour, you are still going to have bounce and scatter. The traffic that's following behind that truck is going to remove that solid material from the roadway surface as they're driving along. Whereas with the direct liquid, it is applied, it is immediately working, and it is making an impact to improve our level of service to the traveling public.
When dry, solid salts are applied to a roadway, the granules can bounce off the road or can be blown off the road by traffic. Some agencies estimate that as much as 30% of the dry, solid salt in each application does not stay on the road. Liquid-only treatments stay on the road better than solids, which results in less waste and less salt going into the environment. Many agencies using liquid treatments have found that their overall salt usage decreases by 25% or more.
What you'll tend to see is liquid de-icing is cheaper than granular de-icing. There's a few reasons why, and the main thing is the usage of material. For example, you can spread salt brine at an application rate of 40 gallons per lane mile. Each gallon of brine has 2.2 pounds of salt per gallon in it, so you're at about 88 pounds per lane mile. Take that on the granular side, and an application rate is generally 250 at the bottom side and could range anywhere up to 350 pounds per lane mile. Studies have shown that the savings is at least 30% when you compare liquid versus granular.
If we can get liquid down prior to a light storm coming in, the cost benefit is not just in the cost of the chemical, but also in fewer truck trips, not needing to come through and plow to keep the ice from forming.
Liquid-only treatments reduce the amount of airborne dust and salt particles. It is also easier to control the application of liquids, which makes the treatments more accurate. This increase in efficiency reduces the cost of maintaining safe roads.
Utilization of liquids allows us to say we can apply this product in a very metered, controlled fashion at the specific spots that we need it on the roadway to be very effective.
How do liquid-only roadway treatments work? In order for salt to melt snow and ice, it must first be dissolved into a liquid form called brine. With solid salts, this happens naturally as the salt interacts with the precipitation on the road surface, but it can take up to 45 minutes for this transformation to take place, depending on weather conditions. With liquid-only treatments, this brine is already made, and it begins to work as soon as it hits the roadway surface. Brine melts snow and ice by lowering the freeze point of water. This means that the snow and ice will keep melting even when the temperature is below its normal freeze point of 32 degrees Fahrenheit. Salt brine mixed to the correct ratio has a freeze point of -6 degrees. However, the salt brine will mix with the precipitation on the road, which will further dilute it. Most agencies use salt brine at an operating range of 15 degrees and above. Some agencies use magnesium chloride or calcium chloride brine instead of salt brine. They are a more expensive option, but they have a lower freezing point than salt brine. Depending on the concentration and manufacturer, some agencies use magnesium chloride or calcium chloride at temperatures as low as 0 degrees Fahrenheit. It is possible to blend either of these brines with salt brine to balance the higher cost with the benefits of lower temperature usage. In addition, there are other materials that can be mixed with salt brine to further lower the freezing point of water and to reduce corrosion. A listing of these materials can be found on the Pacific Northwest Snowfighters website.
You can drop down a little farther with calcium and magnesium than you can sodium chloride brines. Their melting capacity is a little greater initially, so the mag chloride will melt material faster for the first 20 minutes than the sodium chloride will. At an hour, they're pretty much the same, one's just quicker.
Common myths about liquid-only roadway treatments. One common myth is that liquid-only roadway treatments don't work in extreme weather conditions such as heavy snow, high winds, and freezing rain. Despite this misconception, agencies across the United States are using liquid-only treatments in these challenging conditions. During storms with heavy snow, the liquid treatments may not be as effective at removing snow, but they are often used to loosen hard snowpacks caused by traffic, making plowing more effective. In a weather event with high winds, anti-icing with a liquid solution will stay on the road despite the wind, while solid salt could be blown into the ditch. In freezing rainstorms, depending on the projected intensity of the storm, a liquid anti-icing treatment can be used prior to the storm to keep the ice from bonding to the roadway. During the storm, the liquids immediately begin melting the ice. Additional liquid will need to be applied in order to counteract the dilution of the treatment.
But we've even shown on heavy icing events or ice storms that getting that product into the pavement down before that rain or that precipitation comes in, it still breaks the bond with the pavement and allows cleanup and traffic just to keep breaking that up. Yes, it dilutes out, but it still has a dramatic impact on not creating that base layer of ice on the roadway.
Another common myth is that using salt brine results in more chlorides entering local water sources than using solid salts. Chloride ions are a byproduct of salt brine, and high levels of chlorides can be toxic to aquatic life. However, in order for solid salts to melt snow and ice, they must first dissolve into brine. So in either case, brine is being used to melt the snow and ice. With liquid-only treatments, agencies are using less salt, which results in less chlorides entering the environment. This is especially true in locations where solid salts can bounce directly into sensitive areas. Using liquid-only treatments for anti-icing reduces the amount of de-icing treatments that are needed during and after a storm, which can further reduce salt use.
We run a toxicology test that includes looking at fish, aquatic insect, and algae, and seeing if it's detrimental to any one of those three species. So having that in hand helps us go through the approval process. But the biggest concern that I try to promote is do what you need to do to make the public safe, but don't go overboard so that you put too much salt in the environment.
I would say with any sort of salt storage, you need to do your best to protect the environment and the materials that you're applying to the roadway. You want to keep it in a contained area. You want to dispose of any of it properly. Salt brine, rock salt, all of that has consequences if too much is applied to the environment.
Public works agencies are working to reduce environmental impacts while still maintaining public safety. Many agencies utilize road weather information systems and road sensors to obtain real-time information on weather conditions. They use this data to determine where and when anti-icing and de-icing should take place. With this technology-based approach, agencies can further reduce their salt usage.
I think it's important to have something that'll give you a soil temperature underneath your road, a puck in the road that'll tell you the salinity of the product you're putting down and the road temperature, and have a way to monitor and go back after storms and look at what the process is you're doing and how well it's working.
Another common myth is that salt brine causes more corrosion on vehicles than solid salts. This myth is similar to the previous one regarding chlorides. All solid salts need to dissolve into brine on the roadway in order to melt snow and ice. As a result, roughly the same amount of salt brine is affecting your vehicle with either treatment. Some agencies add a corrosion inhibitor to their salt brine or magnesium chloride, but this still does not eliminate vehicle corrosion completely. For this reason, agencies frequently recommend washing your vehicle after a storm event.
In liquid products, we can correctly measure the corrosion inhibitor that's introduced into those products. There's still a lot of studies showing a corrosion inhibitor on a granular product is just not effective. As soon as that molecule kind of breaks down, the corrosion inhibitor disappears, whereas a liquid product that's mixed in is coating that chloride ion.
We do corrosion testing here. We do some wet bench work on things. We'll do pH. We evaluate corrosion percent effectiveness of products. Salt as it stands is 100%. It's at the top of the scale. But all the corrosion inhibited products have to be at least 70% less corrosive than rock salt.
Public works agencies nationwide are working together to share information through organizations like the Clear Roads Group on winter road maintenance practices that are safe, effective, and economical. The advice and recommendations presented in this video are part of this shared knowledge. Agencies with successful liquid-only programs recognize that these types of roadway treatments are only effective under certain conditions and are part of a larger winter maintenance program. When used correctly, liquid-only roadway treatments are a safe and reliable solution for snow and ice prevention and removal.
It's a key component of what we do here in Prairie Lake, and it's a fixture on our trucks.